Hey, we're live. Welcome back. Let's switch over to my screen. All right, so where we left off last time, yesterday, was we just finished being able to save and load. It doesn't work for the browser, of course, but it does work for bare metal compiles, and we can see here a save game JSON file which contains all the save game data. And if I start up a game, it brings me to the main menu, the load screen menu, or load game menu. Soon. There we go. So we can either begin a game or we can load a game. If I hit load game, and we can resume where we left off. It saves the map, it saves the monsters, it saves the items, it saves your inventory. Of course, in this one game I didn't pick up anything. It does not save the game log, but everything else is preserved. So what we're going to start today is now that all the infrastructure is done, we can add depth to the game, so to speak. So let's go through this. We're actually using this roguelike tutorial. You can see here, there's the URL at the top. We've gotten through chapter 2.10, and we're starting chapter 2.11, otherwise known in the URL locator as chapter 12. It's called Delving Deeper. So let's start there. We have all the basics of a dungeon crawler now, but only having a single level is a big limitation. This chapter will introduce depth, with a new dungeon being spawned on each level down. We'll track the player's depth and encourage ever deeper exploration. What could possibly go wrong? So indicating and storing depth, we'll start by adding the current depth to the map. So let's do that. See, all we do is add it right here, and it's I32. So Surdy automatically hands it, so we don't have to do anything special. A map creation code also needs to indicate that we are on level 1 of the map. We want to be able to use the map generator for additional levels, so we'll add parameter also. New map, rooms and corridors. And I think I just called that new map because I didn't want it to, oh no, I called it the whole thing. Okay. Here's tile content and then depth. New depth. We pass in as an I32. New depth I32. Oops. We call this from the setup code in main, so we need to amend the call into the dungeon builder also. All right. So we'll just pass in a 1. Easy enough. We'll modify the player's heads-up display to indicate the current depth. So you can see depth here, depth 1. So we'll just fetch the map out of storage, as a resource out of storage, and then just print the depth. And this is in GUI, right? Yep, GUI. Source lib GUI. And it is in draw UI. So at the end of draw UI, we fetch the game log, reprint the game log. Let's put it right here. Let map ECS fetch map. Let depth. Depth is this map.depth. And then we're going to say CTX print color 243 RGB named yellow. I'm importing yellow so I don't have to do the RLTK thing. RGB named black and a reference to the depth string. All right, so it should show up now if I run it. Wow, I did something that's making it take longer to do that final build link. It wasn't this slow before. Okay, 13 seconds. Wow, that is too slow. So begin new game, and now we can see depth here. Of course, we can't go up or down, but we can see that we're on the first level. So, okay, here we go, adding downstairs. Okay, so let's make sure Clippy's happy. See, that only took that only took 3 seconds. Okay, git add source, git commit. What do we got? Adding a depthometer or a depthometer. Yep, nothing fancy. Okay, so now we're going to add a downstairs. So in map.rs, we'll enumerate tile type that adds a downstairs. Okay. Map.rs there. We have wall, floor, and downstairs. We'll also want to be able to render the stairs. So in draw map, we're going to add a downstairs tile type. Okay. Somewhere we draw the dots and the hashtags. Match tile. Oh yeah, I did it this way. Downstairs. And do we need another color? 110, yeah. I don't know why we're doing it this way instead of using the built-in colors. Right? Well, I guess that's what we'll do. From F32 0.1.1. And we'll add the tile type downstairs. Becomes downstairs and cyan. And then lastly, I assume that green, blue, full green, full blue is cyan. Lastly, we should place the downstairs. We place the upstairs in the center of the first room the map generates. So we'll place the stairs in this. We haven't done an upstairs yet. Okay. Maybe that's coming soon. In the center of the first room the map generates, so I'll place the stairs in the center of the last room. Going back to new maps and corridors, we'll modify it like this. Okay. I'm not going to retype that whole thing. Hopefully it's mostly just... So we've got depth, new depth. We've got the min rooms, min size, max size. Grab the random number generator. Here's our rooms. This looks all the same. I added a break statement there. That's okay. Nobody cares. Okay, right? So all of this is the same. Okay, so the only difference here is these lines. That would have been easier just to put in, but let's see. Stairs, position, map rooms, len -1, center. So we grab the center of the last room we created. Map xy idx, stairs, position 0, stairs, position 1, map tiles, stairs index is tile type downstairs. If you cargo run the project now and run around a bit, you'll find a set of downstairs. They don't do anything yet, but they're on the map. Okay, let's find them. Let's see if we can build it. Oop. I was about to say we didn't do anything controversial, so it should just all build. But of course, if you typo things, that's going to happen. Yeah, wow. What did I do? 12 seconds. Okay. That was a long time. Okay, so we should be able to now run around the map. I should pick up health potions and things. Oh. Let's begin a new game. There we go. Grab a couple health potions, because we're going to have to fight our way. Probably. Unless the downstairs happens to be right. Nope. I was going to say, unless it was right there. Alright, so we're going to use a fireball scroll on... Can I target here? Yeah, That way it doesn't hit me. That is not a downstairs. That is a magic missile scroll. No downstairs there. Ah, okay, let's gonna do another fireball on this guy. I don't like the way they hide on the corners there, and they get stuck on the corners. I don't know if that's a bug in something I did or a bug in the code in the tutorial. Oh, I died. I wasn't paying attention to my health. All I want to do is find the downstairs. I don't need confusion. I don't work well with confusion. Ooh, 2 orcs. Let's cast Fireball. Hopefully hitting both of them. We'll regenerate our health. And keep looking for the stairs down. We should add a scroll of magic mapping. Ooh, another fireball scroll. There we go. Okay, so now we're on the downstairs. We can't go in downstairs. I'm using the down arrow, but it's there. Okay. So let's check that in. Clippy. Okay, nothing spectacular there. It all looks good. All right, and actually going down a level. In player RS, we have a big match statement that handles user input. Let's bind going to the next level to the period key on US keyboards that's greater than without the shift. Add this to match. Okay. We have DGI. Let's put period right here. Oh, we have to do some code. If try next level, which doesn't exist yet. GSECS, return, run, state, next level. Okay. Of course, now we have to implement next level. So we already have a try move player, right? So let's add try next level. World. Like that. Let player pause. ECS fetch. Point. Let map. Let's move this up a bit. ECS fetch map. So we get the player position and the map position, and then find out the player's location on the map. And then if map.tiles of the player's index, tile type downstairs, then we return true. Right? Otherwise, we grab the game log and tell the player you can't go down. ECS fetch mute. Game log. Game log entries push. There is no way down from here. To string. False. Okay. The eagle-eyed programmer we'll notice that we returned a new run state next level. Since that doesn't exist yet, we'll have to add it. Okay. And it is in game state. So there's save game and then next level. Your IDE is by now complaining that we haven't actually implemented the new run state. So let's go into our ever-growing state handler and add it. All right, and that's in here. Run state, new, next level. Self go to, next level. New run state pre-run. Okay, and now we have to add go to next level in our state impl state. It's down here. Let's put it at the bottom. So entities to remove on level change. So what is this doing? It grabs a list of entities, it finds the player, it finds everything that's in the player's backpack, and it finds the player entity as the resource. Oh, this is read storage. So this is finding a list of all the players. This is finding a list of everything that's in any backpack. Okay. And then we grab the actual player from the resource list. And we have a list of all the entities here. So then we go through all the entities. If it's the player, we say should delete equals false. And then we come down here and we say I'm trying to follow the logic here. So then we said should delete equals false. Then we look to see if it's a backpack item. If it's in the backpack, then we also said should delete to false. And if should delete is false is true, then we push it. So if it's a player, I'm going to simplify this code a little bit. And hopefully not break it by simplifying it. To remove on level change, which we're not calling from anywhere yet. It must be the go to next level function, right? Back entity. So this says, give me a list of everything we need to remove when we're changing levels. And this generates this to delete vector that we return down here. I can see that. All right, so we're going to grab entities, self ECS entities, right? And we're going to grab the player, or we're going to grab a list of all players, which should just be one. Right, every player entity, let backpack, self ECS read storage in backpack. Right, so that grabs a list of every entity that is in a backpack or has the in backpack marker set. And then player entity self ECS fetch entity. So this grabs, these two lines here read all entities that have the player component and all entities that have the in backpack component. These two lines, this grabs a list of all the entities in our ECS, and this finds the one resource that we stored that was a reference to the player entity. Okay. So now we're going to create a list of entities to return, right? And we're going to, at the bottom of the function, we're going to return it, right? And now we're going to go through all our entities. Now I'm going to, like I said, I'm going to simplify this a lot because this doesn't need to be like this. The setting is should delete to true, right? If we're a player, then we said should delete to false. Then we come down and check to see if it's in a backpack, right? And if it's in a backpack and the backpack owner is a player, then we don't want to delete it also. And then if we haven't hit one of those two cases, then we're going to push this here. So this can be simplified. We don't need to check this if we've already hit this, right? And we can also short circuit the whole loop by doing continue. So that's what we're going to do. Entity in entities.join. We're going to eliminate this whole Boolean variable here just by saying if player.get entity is sum. So if this entity, as we iterate, we found the player entity, we're just going to say continue, right? So that takes care of this logic here. Now we're going to look to see if it's in the backpack. If let sum backpack is equal to backpack get entity, then we're going to check to see if backpack owner is the player entity. We're going to continue. And this, now that we wrote it out, we can simplify it even more just by putting an and there, right? And doing that, right? And then if we're not continuing on both of those, we're here. So to delete, push entity. So that simplifies the code rather a lot, I would say. And I think this does all the right things. But we're still not done yet because we have to write this go to next level. When we go to the next level, we want to delete all the entities except for the player and whatever equipment the player has. This helper function queries the ECS to obtain a list of entities, right? That's up here. It's a bit long-winded but relatively straightforward. You make a vector, right, here, and then iterate over all the entities. If the entity is the player, we mark it as should delete equals false. If it's in the backpack, we check to see if the owner's player, and if it is, we don't delete it. I would want to rewrite this part here. Armed with that, we go to create the go to next level function, also inside the state implementation. Okay. So that's here. Go to next level with a mutable reference to self. So delete entities that aren't the player or his/her equipment. Let to delete equals self entities to remove on level change, the function we just wrote. And then we're going to go iterate over them. Self ECS delete entity target expect unable to delete entity. Okay, so that cleans up the level. So the player remains and everything in the player's backpack remains. But everything else in the level has been removed. So build a new map and place the player. Let world map semicolon. Let world map semicolon. What is this doing? Let mutant world map resource is the right resource in the map. So we grab the map as a resource. We find the current map's depth. We generate a new map with current depth +1. That makes sense. And we store it back in the resource. And then we grab a clone of the map and assign it to world map. Okay. Well, in the interest of continuing the simplification theme, we're going to do it this way. Let mute world map resource. I'm going to save a half a line of code by doing this. Self ECS, right? Resource. I don't like this part here where you declare the variable and then you assign it later, and then I think it makes it harder to read the code because you have to go hunting for where the assignment happens. But if we say let world map equals and then we just return the new map clone here, I think that makes it easier to understand what's going on. Current depth world map resource depth. We assign it world map resource map new map rooms and corridors current depth +1, and then we just say world map resource clone without the I, and then we just don't put a semicolon, and that assigns world map like that. Okay, now we spawn the bad guys. Well, we're spawning the room, which does the bad guys, and it goes, yeah, I agree, Togglebit. All right, so this spawns the bad guys, and it also spawns and rooms and items. Why did I do that? Okay, for room in world map rooms iter skip 1, and we call the spawner to spawn the room. So we just generated the room here. Spawn room is, let me pull that up. Source lib map. Oh no, it's in spawner, obviously. So spawn room fills a room with stuff. So what it's really doing is spawning monsters and items in a room. The rooms are created with this function here, new map rooms and corridors. So mute self ECS room. All right, and then we're going to place the player and update resources. So we're going to grab, yeah, it's this is I think this is my specs tab. Sorry if this is a little blinding. I'm not sure why it's not in dark mode. But this is specs. It's actually part of this thing I'm using here called Roguelike tutorial. Roguelike tutorial uses RLTK, which I should be able to, RLTK. It's on GitHub somewhere. Yeah, it's called bracket lib now. At some point I need to update my code to use it, but I started before I realized it was renamed to bracket lib. But bracket lib uses specs under the hoods. Yeah, see, RLTK wraps bracket lib. So we're still using that. Where was I? Okay. So, here. Place the player and update resources. So we get player X and player Y. We're using a clone of the world map here. So we shouldn't need to worry about references and borrowing and stuff like that. Self, he says, right resource point. So the point resource is the player position. There's only one point resource in the game, and that's always the player position. But we also store the player as an entity as a resource. So we have to keep both in sync at the same time. Not a fan of that, but we're just following along with the tutorial. Player Y, and then position components. So everything that has a position, right? And then let player entity self ECS fetch. Yeah, this is the one and only entity resource that's in there. So that's the player. And this is the one and only point resource that's in there. So it's the player's position. And then we're going to, I'm going to simplify this. If let some player pos comp position components get mute player entity Then we're going to set player pos comp x, player x, and then do the same thing for y. So I simplified it a little bit, not a lot. And then we're going to mark the player's visibility as dirty. So that way we regenerate the view shed. Yes, so center is, this is actually part of the a little bit of the code we wrote at the beginning, very beginning of the tutorial in rect. So rect is just a simple x1, x2, y1, y2 thing, and it has a very simple intersection and center function. And it returns a tuple of the center of the room based on the coordinates of the room. It just averages the x and y positions to get the center. So this destructures it here in player x and player y position. And we do need to destructure it because we have this issue that the way the map code works, when we haven't, this is something I'd like to address, but we have to convert it into an XY index separately and then reconvert it back into an index because the map is stored just as a list, which is a good way to store the map, right? But you just have to calculate row column, convert between row column and index all the time. But if you're, yeah, if we store this just as a tuple, we should be able to just store it here as a tuple. I don't know if I want to try doing that now. Let's get this working, and then maybe I can try saying, maybe there's a way to say player pos comp equals player world map center, right? Just the result of this. But I don't know. I don't know if that's possible. I don't know Rust well enough. This is part of the reason I'm doing this, is so I can learn more Rust programming. The view shed is a thing that the user, that every entity can see, and every entity with a view shed has access to in the map. So we just have to regenerate it. Now that we've placed the player down, we got to tell the, why does this guy do this all the time? We can just do this. Vs dirty is true. Okay. Now we can notify the player and give him some health. So, okay, so we've just gone down a level. Yeah, I really like it. I want to get to know it a little bit better because it's still a lot of aspects. I've been watching John Gingsit do his crust of Rust things, and it's way beyond what I know about Rust, but I'm trying to absorb as much as I can, and so that when I get there, I'll say, oh yeah, I know that. I remember learning about that, and then I have to relearn it anyway. So we're going to grab the game log. You send to the next level and take a moment to heal. I think it's just toString. Yep. And then cargo format's going to reformat it for me anyway, so let mute player health score. Combat stats. So combat stats is something that every entity has, so we just have to find the player entity's version of that. And we're going to do the sum again here. Store get mute. player entity. And what are we going to do? We're going to add half the health through the max. Okay. Max HP over 2. So we're going to add half the max health. All right. All right, that's the whole thing there. All right, we use a helper function to obtain a list of entities to delete. Yep, that's this guy up here, entities to remove on level change. We create a world map and enter a new scope, right? That's here. We get a writable reference to the current map, and then we overwrite it on this line here. We spawn all the bad guys and items. We grab the first room and put the player in it. We obtain the player's viewshed component and set it to dirty, so we regenerate it. We give the player a log entry so to say that they've descended, and then if their health is less than 50%, we boost it to half. Okay. So let's try. First, we'll see if this compiles. And it does not. So now we get to work our way through these. So in game state, this should have been okay. I wonder what I did wrong there. Okay. Oops. 224. Oh, there's no let there. Okay. So that's that line. And then we have this one here. Not found in the scope. Okay, I have to add point. And so this position didn't work, probably because of the same reason. Oh, and then this has to return true out of player. Okay. So I have to add point here, right? And then player try next level needs to return true. All right, what else? All right, so line 270 of this guy. Let's see what I did wrong there. And player index. Oh, IFX. Oops. Oh, it must be in a different file. What was it? 270 of game state. Yep. All right, what did I do wrong here? This looks okay. Oh, if let. Okay. And then we have that's that one. And then player here is IFX. Should be IDX. Right? And then we're back in game state. Position is not found in the scope, so 263. Should this be player position? Oh, position components. I put a dot instead of an underscore. Okay. Let's see how much that cleaned up. Not enough. Source lib game state, so 277. And then we'll figure this out. Oh, you can't do them both at the same time. Okay, that's too bad. I can't put an and there. I'll fix that. So 277 I gotta fix, and then 228 is where that problem is. That's missing the if. was and. Oops. It's probably only and in here, right? Yep. Okay. So we do need to separate this out like that. That's too bad. Oh, so 279 is still not good. Player health score. Oops. Okay. All right, looks like that's running or building. Let's try running that over here. I'll make it slightly bigger. Yeah. And refresh. Begin new game. Okay. Let's grab a bunch of items and see if we can find the downstairs. Oh, first we should be able to tell, it should give us an error. Yep. So if I try to go down, it says there's no way down from here. Monsters. There's the downstairs. Okay. So we should be able to go down. Let's see if it, oh, look at that. Depth 2. And now we're on a new level. Of course, there's no upstairs yet. We haven't done that part. But we've gotten down to the next level. Of course, this level is identical to the other level. There's no differences. But I guess we'll work on that next time. Or in the next chapter. Yeah, so the next chapter is difficulty. Which I'm not going to... Adding a wait key. Okay. Currently you can advance through multiple dungeon levels, but they all have the same spawns, right? Okay, so I'm out of time, unfortunately, but we'll get to that on Monday. Let's make sure Clippy's happy. Good. Git add source. Git. Let's make sure that's everything. Yep. It was just those two files. Can now go downstairs to a new level. Good. Git push. And that should show up in my GitHub. And it does. Very cool. All right. Well, that's it for today. Let me click on my brand new closing screen I created. Let's see. How do I transition? Okay, so I'm going to have to set that up because there's no sound on that one. Anyway, thanks very much for watching, and I will see you next time. Take care.